be called TA Day. No, today is well, what do you call it? Tutoring Day, huh? Tutoring Day. Okay, so we have basic source code examples down here. If you click on this link, you'll download the file called OCB code or basic code. And if you do that, you're going to get this group of files here, which is about, okay, how many did I promise? 1, 2, 3, 4, 5, 10, 11. 11 projects that are all going to show you something about Objective-C programming. And let's start out with the one called arrays, because all of the programs are going to require you to do something, and lots of what you're going to be required to do are in these examples. So if I open up the one that's called array, we can sort of see what it does. And the programming examples are meant to sort of show you, you know, how to implement certain things. It doesn't mean anything to show you a PowerPoint, you know, because then, you know, I've actually showed you a PowerPoint on how to create arrays already. A lot of good that did. So,
we need coding.
We need coding. We need to look at this. So you can download this, and you can use anything you find in these examples to help you in your programs. We have nothing but one file in this particular project called main.m, and this is a Coca project. It's not an iPhone. None of these projects are iPhone. They're all for Coca. So if I run the program to show you initially what the program does, I'm going to see the output down here. It's a command line program. What is this program doing? It is, yada yada, printing out a bunch of stuff. Static arrays, me, myself, and I. Mutable arrays with 1, 2, me, myself, and I. 3. Sorted mutable arrays in alphabetical order with the IMOT, with the numbers in order. So that's everything you ever wanted to know about arrays. So let's take a look at the code so you can kind of understand what's going on. Don't ignore this message about C string depreciation. It's using an old C library, C strings actually. So it's, you know, the learning objective wasn't necessarily on the library usage. So there's a function at the top called print, and the print function has in it the one parameter that it's going to take, and the one parameter that it's going to take is going to be called array. This is very C-like, by the way, and you may use this syntax in your Objective-C programs. As long as you write it in Objective-C, you may mix and match C. But in this particular case, this is an NS object. This is of object type NS array, and the object type is array. So it's a really good example. It's going to take any NS array and print it out. So it's going to do, it's going to take an NS enumerator. Well, if you remember what I said about containers and iterators and things of that nature, well, this is one of those kind of objects that you can create. This one's called an enumerator that essentially creates object enumerations for instances of the array, indexes of the array. So we have index 1, 2, 3, 4. It's going to enumerate out all the components of the index values of the arrays and assign them to objects. And it's actually kind of an interesting example because it's using ID object.
Like a counter one kind of thing?
How do I describe an enumerator? Yeah, it's kind of like the enumeration is a counter / organizer. In C, we create enumerations, and the enumerations are like, you know, red, white, and blue. And these would be colors of the flag.
Like constants?
Yeah, constants, kind of
Okay.
like constants that represent integer values. And the integer values are, in the case of the normal C enumerator, it would be a 0, 1, 2, 3, you know, numerical numbers. In here, the enumeration is going to be the object, next object, next object, next object, which is, if you think of, I remember the Java class when we looked at the built-in stacks and queues when we went next and next and next. This is a method here, next object, on the enumeration class. The enumerator, see, NS enumerator, we're going to call it enumerator. It's a pointer because it's an object. It's going to be equal to array object enumerator. So we're going to take the array, we're going to enumerate them out and get each one of the indexed objects and call it an item in our list. Think of it like a list if you want to think of it that way. Which is why this works. So if I say object is equal to enumerator next object, it's going to go into that enumeration and say, give me the next one, give me the next one, give me the next one, and pull out each object and assign it. And print it out to the screen. Here we have the object description, which is going to be on the object, which is going to be of type of a C string. That's going to be, and this is where the compilers actually not really complaining. He's just saying that C string is depreciated. I probably should use NS string for it. But NS string is going to give me a different type of syntax. So let's just leave that one alone. So you can use depreciated objects, no problem as well. So you see I'm using the auto release pool with the opening and closing brackets at the end. And inside of main is creating an NS array here. I'm going to call it array. It's a pointer. And this is going to be an NS array alloc. We're familiar with that, I hope. And then initialize with objects. And we're initializing it with me, myself, and I, essentially. Me, myself, I. And then we're going nil to say there's no more objects in here. And the next line of code here is going to do another array. So these are the formats actually for the two data types. So NS array is the non-mutable. It's the, and when I mean mutable, I mean changeable. In C we had arrays that were, just the array data type. Once you set the size of the array size just stays there. Mutable means it can grow, it can get, well, it can always get smaller, but can it get bigger? That's really the challenge right there. So an Objective-C has a new data type called mutable. So NS mutable array, mutable, is essentially the different, it's the same thing as an array, but it's just mutable, just changeable. Because if we go over here, we see the enumerate over the items here, print, and this is the static array, print array. We're sending it array, which is the name of the first array. And so print up here is taking this parameter as an argument, and it's creating an enumeration out of it. And while the object has an X to it, we're going to be printing print out the object along with its description to the screen. These are all built in. Basically the description is the object name, what we added into it, which is 1, 2. Actually, in this particular case, me, myself, I.
Print is a method and ARR is an object which we are taking.
Yep. The ARR here is the name of the object for the NS array, and then mutable is the name of the object for the mutable array. And then when we print this ARR, or we print mutable, and then we're going to change the array and print it again, essentially in this code. Mutable is the same type up here. They're both NS arrays, but mutable is a kind of a subclass of it, which, an object is another object. So we can take and use the subclass as the original parent class in this case. So it's kind of a polymorphic function call if you think of it that way. But the enumerated over items static array. The static array is going to be essentially this array that we created here. And then we're not going to be able to add, we just basically say here's our array, and then we use the array. If we want to create a mutable array object, we can add the object 1, add the object 2, add objects from the array, and we're going to add it from the array. So we're going 1, 2, and then add our other array. So rather than just adding 1 item, 2 item, we actually added 3 items to it at this point. And then add another item, item number 3 to it, and then print them out. And we print them out, we just print mutable. And then sort, when sort then print, we're going to run sort using selector, and the selector is going to be case insensitive compare, which is essentially going to be the method that's going to say, well, compare it, sort it by its alphabetical order, which is essentially the default behavior when you compare the list of strings. So don't worry about this part. I don't believe you have to do that for any of your assignments, but you do probably have to create an array for the first assignment, is what I'm thinking. I'm not sure. Or one of the assignments, a couple of the assignments perhaps have you create an array. The ships, you have to create an array of different types of ships. Well, you put the object in here instead of the string, essentially. You can, in fact, here, look at here. We added an object, an array object. Add objects from array. Well, you're going to have one that says add, add object. I'm like, I can't give that away to you, but you're going to have something where you're going to make, I create a mutable array. That way you can add stuff to it if you want. It doesn't really matter, actually. It's just an array in general that you're going to create.
So is this code, this is for string actually, so even it's same for the numbers as well?
Yep. Do you see any data types associated? No? It says alloc array here.
Case insensitive comparator means that is must be for the string.
This is for sorting it, by the way.
Yeah, so but even for the numbers also it's same.
I believe you're going to use a different method for numbers, and you'll have to look that method up. And that's for the apple.developer.com website. There's one specifically for Objective-C, and I believe I put the reference to that in the course notes, the book for it. That's going to tell you what method to actually run on that. But you could have essentially, put, well, this is going to give me, I have to actually convert it or treat it as an integer. Incompatible integer to pointer conversion, sending int to parameter because it's an int. I'd have to actually, if I wanted to put numbers in this particular one to make it, well, let's see. I'd have to actually implement conversion, incompatible integer pointer conversion, sending int to parameter. Let me see. I'm trying to think. Well, I'll let you do it. Integer to ID is disallowed with automatic reference counting. That's because this isn't an object. You're not going to have this problem actually, because you're going to be putting objects in there. It's having. I'm going between objects and primitive data types, so I'd actually have to print this and treat this like an integer object instead of a number, because this here is actually an object. It's a string object. So I'm getting this error message because I'm going from a primitive data type to an object type, and this is expecting an object type because this is of an object type. So I'd have to use an NS string or an NS integer, declare some NS integers, and then put those integers in there, or something of that nature in order for that to work. But all right, so that one is that one. Actually, here, let me fix it just in case I want to go back to it. This is meant to be an example to show you how to create some arrays, actually.
Because most of your, for example, also with the strings,
Mm-hmm.
but we have to use with numbers.
Mm-hmm.
So it took a long time for me to get the code for the numbers. But I
NS
got
integer.
Yeah.
It's an n-number object.
Yes.
That's pretty much, you can use the same way as an NS string. Yeah. No, I'm not going to give you.
The whole code.
Yeah. No, that was too much. I can't, then it wouldn't be an assignment, would it? That's actually for you to figure out, for me to know, for you to figure out. Alright, here's another one. It's called ID. And it's emphasizing the point of the ID. In fact, we've seen this example already, but I just thought I actually, it got cleaned up a little bit, and it got transported into another example. This is, remember the one with the fraction and the complex? We had a complex number and a fraction, and this one was actually for classes. So in here we have class object, and we're going to call this class object in this particular case complex. And complex is a real imaginary, and then we have a real and imaginary. We can set it essentially, initialize it kind of a couple of different ways here. We're going to initialize it up here, complex. So this would be the initializer. So this is not a bad one to look for in terms of initializers. And then real imaginary, and then another method down here called print. And then over here in the complex class .m, we're gonna implement complex. And in here we have, and actually I can get rid of the sidebar here. We don't need that. We have complex with integer with real, r, and imaginary. So this is the implementation of the initializer. So this is not a bad one to refresh or to help you with the initializer concept. And we have two pieces of data in here. We have a double real and a double imaginary that are part of this. And we're inheriting from NS object, by the way. So in here, we are doing nothing more than setting the real or setting the imaginary, and or setting the real and imaginary. So these are non-automatic setters and getters. So it's not using the property in the synthesize. But you know that property and synthesize is kind of a easier way of doing it.
That was my question. I was thinking to ask the question and you gave the answer.
Yes. You could do this with property and synthesize. The only thing here, though, is that these are double numbers. They're not really objects. They're, again, primitive data types that are in the language. So, and then we have fraction, and fraction over here is, again, two integers instead of numbers, a numerator and a denominator. And then we have another initializer. And I believe I think the first, or one of them says to use properties and then synthesize. The other ones I think are like optional. I don't really care if you're using the property or the synthesize method.
Yeah, it was optional.
I think it's optional. Yeah, one of them I believe requires you to do it. One of them says use property and synthesize. But the other times I think, do it any way you want. So this one particular one, it's all done manually as well. I hope you guys remember what the synthesize and the property are doing at this point. In terms of the implementation, we have another initializer here. This one was really good, by the way, just to show you the initializers. So now what we're going to do is essentially make some instances of these objects. I'm not going to go, actually I've gone through the object code with you in a previous example in a previous class, but if I take a look at the .m file, this is the part that actually looks interesting. I have ID number right here, and then number is equal to a fraction here, and the number is equal to a complex number here. So I've gotten a generic object that I'm using to reference two different object types that have nothing to do with each other. They're not actually inheriting from each other. This one here I forgot to mention that the fraction is coming from NS object and complex is coming from NS object. So can we use ID to mix and match data types? Sure, why not? Or object types actually. So here I have ID number, and number is equal to fraction, and number is equal to complex, and number is equal to number print, and number print works just fine. And all of the essential functionality is done with a kind of a generic reference type. So if we print this out, this is actually the same program that we had before. It was just converted to use ID. So you've seen this example already. This is the one that prints out the fraction is 1 divided by 10. The complex number is 10 plus 15, whatever. And the output's really insignificant. What the learning objective here is to know that you can make it a generic object with ID, and then take that object and assign it to any object you want. If I had like person, create a class, put it in here, call it person, I can take ID is equal to person, or number is equal to person now instead. So, and in here, over here, we have our two instances, fraction and complex, where we've allocated two fractions, one fraction and one complex number. So it kind of demonstrates the use of the ID. I'm sorry? No, I didn't ask you anything. Any questions on the ID? Now I can ask you something. Yeah, moving right along.
Even in
Yes?
the assignments, I think you asked us to do in the same package with the different classes. Because you gave the 3 parts, so we have to use 3 different classes, which may not be related to each other.
Correct. And so you can use an ID to keep track of your ships, your cruise ships, and everything else. When you put them into an array, it can be of a type ID, actually. And then you can take those ID objects and you can stick them into an array. Or actually, you can just stick the objects in the array without using ID at all. But, it makes one class, and let's talk about ISA relationship, actually. And I think this is going to be in the type example. So let's say you have a bunch of ships and cruise ships and objects, and you want to know what they are. Well, you have to use like an ISA relationship to it. In fact, I think the first or second assignment also has the ISA kind of concept to it. What am I talking about? ISA, being able to tell what the object type is without actually programmatically setting the type. So in this particular program, let me run it so you can see what it's doing. It's actually a modification of a square and rectangle assignment, or program that we've seen already. These are recycled, but they have different things added to them. So we have square as a member of the square class. Square is a kind of square class. Square is a kind of rectangle class, because we have rectangle and square. There's some inheritance going on here. Square is a kind of object class. And square responds to set size method. Square method responds to alloc method. These are just some printouts that are happening when certain things happen in the methods. And the square instance responds to the set size method. So let's take a look. I have one unused variable here because I made a rectangle, but I didn't use the rectangle. So let's take a look here. We have a rectangle, And rectangles, everything's done manually in these examples. There's no properties and there's no synthesize. But rectangle has a width and a height. And we have an initializer here that is a type rectangle. We're going to initialize a rectangle with a height and a width. This is a slightly different example than the rectangle and the square that I had shown you a couple weeks ago. In the rectangle.m file, we're doing the implementation for it. Nothing too fancy. Set the width. Well, then the width is equal to W. Take it in from the command line. Set the height. Get the width, get the height. Print the width, print the height. And then we have square. Square is inherited from rectangle. So this is, if you're confused with, if you're having problems with the inheritance part, this is a good example. This is the same inheritance example I gave you a couple weeks ago, actually. So it should look a little familiar, maybe. There's the implementation of the square. This is kind of interesting. So you're making a square, although it's coming from rectangle. In this one here, we're making a rectangle that's coming from NS object. So it's just kind of interesting. In terms of the implementation, it's going to be pretty much the same as the rectangle, little square here. And main is the important part. So let's take a look at main, because we've got to run some we're going to run some functions in main. Here it is here. Is member of class. Just like is a relationship in Java, is a member of, well, this is just kind of similar syntax, worded very similarly actually, but it does the same thing as well. So up here we have a rectangle that's not being used. Actually, I can kind of go like this. Well, not really, because we're going to check the type of the rectangle, I think. But I'm not doing anything with the rectangle. So we created a rectangle rec and a square square, and then we're going to use the is a member of. So this one's going to come out true. Square is a member of square class, and this is the interesting part here. The syntax is a bit different. We're saying square class, meaning return my class. If it comes back to equal to true, that in our comparison we came out with square, and our object is a square, then the square is a member of the square class. And then rectangle is the same test, is a member of this class. Or else, square is a member of the object class. Well, it's also an object as well.
So it is asking square class is equal to square class.
Yeah.
Okay.
Is the square class equal to the square class? Yeah. But it's SQ, which is an object of reference type square, which is how it's really saying square is equal to square. Yeah, of course. Or we have is a kind of. So it's broken out by method type here. So is a member of class versus is kind of class. So square, now we have square, square, rectangle. Is square is a kind of rectangle class? It is actually. Because square comes from rectangle, it's inherited. So in the square implementation, it's inherited from rectangle. But it's not a rectangle. It's a member of it, but it's not a rectangle. So is it a member of the class? Well, actually, what is our thing? It is a member. Square is a member of the square class, and it's also a kind of, a kind of, a kind of. So we have square is a member of the square class, and then square is a kind of square class. It's not a member. Square is a kind of rectangle class, but square isn't a member of the rectangle class. Rectangle is a member of the rectangle class, though. So, because we don't see square is a member. We only see one member here. Square is a member of the square class. So we can kind of tell what the object is, and then what the other one part here, the second part of this as well, is it a kind of this class? Is it a variation of this class versus is it this class? This is what we're testing for. Square responds to the set side method here. Responds to selector. Yeah, is it going to respond to it then? Square responds to it. So these are all different methods that we're doing on the object to test what it is. One of the assignments specifically, I believe, wants you to do an is a member of kind of check. This is what you're doing for it. You're kind of sort of saying, is it a member of that? Is it kind of that? So you can kind of test what it is. And then we have instances respond to selector. So square instances respond to set size. Square class responds to something. So instances respond to selector. which is a slightly different method, running on rectangle and running on square. So
all are like true.
not all of them are actually. If you go through here, for example, which one on the bottom one? Instances that respond to selector. Rectangle is instance responder to selector. Yes, rectangle.
So if anything would go to false, means it could be a square is a member of a rectangle square.
If it goes to false, it means that the method isn't there in the class, or it's not a member of the class, or it's not part of the family tree. See, this is a great way of assessing. Let's say, for example, if the method's there, then run it. If the method's not there, then don't run it. Because all these objects come into the system, and you're trying to figure out, well, I want to print it. I can tell without making an error if the object has a print method. If it does, then run it. If not, check to see if it has something else. So it's kind of, it's an interesting way of doing some debugging actually on the code while the program is running. So it's kind of interesting that way. Because you're checking things about the object essentially. And it has something to do with the type of the object actually, which is why the project's called type. Questions about object types. Okay, moving right along. So we did types. Actually, I have to keep track of what we did, what we looked at. And all these you can download and look at them. We did arrays. We did IDs. Let's look at access because you had some questions about public, private, and protected. And, access. Yeah, so how do you make something private? Well, actually, believe it or not, things are private by default. Data members are private by default. But take a look at this object here. Something a little C-like, in my opinion. Not really Objective-C-like, but it works in Objective-C. We have public variable, 2 private variables, and 1 protected variable. It means what you think it means, actually. Same thing in C++. And if you're not familiar with C++, so public is public. It means it's open to the main. Private is open within the class. Protected is open through classes that are inherited from this class. So if the class is an object of, is a kind of this, then it's available. So you can test to see if it's available by using what we just saw in the previous example. And then you can change this value. Not really a good idea, because what we really want to do, if we leave out all these public, at private, this is the syntax for it, by the way, and at protected, we'll leave it all out, it's automatically private. And then we use the data members to make it public. Or we do use the data members to change the values of the private data members. So member functions change the data members. So let's take a look at the .m file that's associated with it. Nothing to it. The .h file is inherited from object. The main file here is the interesting one. So it's making an instance access A, access alloc. And so we don't have any member functions, we don't have anything, but instead we're going to treat this, and this is an array, by the way. Excuse me, an array, it's a pointer. So we have this asterisk here to say that this instance of the object is a pointer object from access. Nothing too new here. But this is the new part you might not be familiar with. This is in lieu of dot. So if this were just a regular old integer value or something, but we have an object here that's a pointer object, so we're using this notation instead of the dot. And we're setting, this is very non-standard, which is probably just, maybe it doesn't look familiar to you. I don't know, but if this were not a pointer, if this were a regular object, we would go, a dot public variable equals 5. And if I did that, we're going to get a message here that says it's a pointer, it's a reference. Property is not found in the object of, did you mean that the object to be accessed this way? You fix it with this pointer here. If we do that, now we have the correct symbol that's going to be used because this is a pointer variable. So this will work actually. Normally we would set the value of public variable using, something like a method call for setting it. Public variable, is equal to 5. From a method instantiate from a method call, using opening and closing brackets. We're setting in getters from the property and synthesize, but we don't actually have to do it that way. So public variable is this. This won't compile because this is a private variable. So if I run the code here, we see it working. If we try to compile the code, and we see public variable 5 is the answer here. This is what shows up on the screen. If I unhighlight this code here, I can go, well, it's actually going to, Xcode's not going to let me, not even going to let me compile, but I should get some sort of error message. Oh, build failed. Instance variable is private, which means it's only, you can only do this, you can only print it out and do something within the class. Well, which is why we have the setters and the getters. So we can, and I call them setters and getters, but they're really modifying and or accessing the data members of the class through member functions. So, which is its sole purpose of setters and getters is to get rid of this problem, because we don't want to make the data public. So, if we make the data public, then this object here, as we've seen, can actually modify. We change this value to 5. And so you're thinking, well, okay, but was that allowed? Is that going to destroy the integrity of the rest of the classes or something? And so it might break our rules. So if we create member functions for that, then we're ensuring that the rules aren't going to get broken. We're going to change it to something that makes sense. So, questions about the access methods? Yeah?
Then what's the reason making it private when we cannot use it?
Watch this. You can make it private. So I'm going to go down here as an example, and I'm going to say, let's make it so it actually works. So I'm going to say void set I wish I didn't call it private. I'll just call it private variable. This is the H file, I hope. Yeah, and then what are we going to return? What integer? This is the return value. Get private variable. So now I've made some setters and getters. This is private, by the way. So I'm only working with these guys. So I'm going to just work with one of them. And then in the implementation here, let me make this way so I don't have to. My typing is really bad. I can come up here and I can implement these two methods here. And let me get rid of this error messages first. And here I'm going to say, oh, I have to give it some parameters, don't I? Let's just do it this way here. I didn't give it any parameters to set the number. So let's just return the number. And the number's not going to be set to anything actually unless I manually set it. I'm gonna set it in here, which would do the same thing as the setter. So private variable is equal to 10, and then printf. This is the value. Okay. And let's see. And it's going to be private variable. And let's see what this error message says. Control reaches. Oh yeah, because it's return. I probably should just make this void here. Wait a minute. Just make this one void too. I should just decide what I want to do before I do it. Void. There we go. Okay, so I'm going to only implement one of these methods here. It's going to be a void method. Conflicting return type to implementation of get. Yeah, I know. Okay. So back out here in main, I'm going to run the method here. Instead of running this code here, I'm going to run this one. I'm going to go a. Oh, actually, I can do the a dot. Yeah, I wonder if this would work actually. I think well, normally I would do this. I would go a space. What was it called? Get something or get private variable? I don't know. Which one did I implement? I implemented get. Well, this is telling me, well, get normally returns something. Okay, let's just get rid of these integer. I know. I'm not following the standard. Now I have to change it over here too. I didn't implement my it's an empty method body, so I'm not going to run this one. I'm going to run this one here. And I'm going to say, why do I have this here? Void method. Okay, it's not synced up yet. So watch this. I'm going to go project clean. I'll sync it up now. There we go. Okay. It's just going back and forth. So I'm going to run the get private variable here. This is going to print out the value of this variable that's private. This is how you're supposed to do it. And then if you print it out, you get this is value 10, which is the value of that private variable. I set it in here, but you could use this method to set it, and which is how you're supposed to do it. And if I did that, I should probably pass it a value. Probably pass it an integer value, so I can pass it in. But it's just demonstrating essentially the concept. So if you keep it private, then you use these methods to set and get it and to move it out, which is what you're supposed to do. So, and this doesn't work.
This is
private.
private data. If you want to private
It's an access method.
Okay. If you want to private class.
Why would you want to make a class private?
We have a project. We have an assignment, and first thing we have to private class.
Which one is that?
First.
You did? Which one? Let me look at the assignment actually. Now, assignment number 1, let's take a look at the assignment. Because there's probably a reason for it. Let's take a look here.
Actually, there is no class that is private, so you have to tell like there will be a connection between first class and second class. So you told me, so I tried to remove it. I don't know how to do it.
But it's working? Oh, that's all that matters, really. All that matters is that it's working, right?
To create a new class,
So I got the assignment here. Let's take a look here.
I think objects equals extension and
Yeah.
created that thing and and I did. So
Let's see. Is this the right one at least?
Yes.
Okay, good. Is it in part 1 or part 2? Part 2. Okay, so part 2 says the methods are functions, okay, that are defined on a class in order to create a new project in Xcode. You can use the same project as created. Create a custom class that contains at least 3 public methods and 1 private method.
That's what
Method, yeah. Not a class. So you're not creating the entire class, you're creating a method that's private. And if you do that, you can use the @private, actually. Why do you want to use a private method? See, this is this method, 1 private method. Not class.
okay,
Yeah.
still
But if you create a private method, you can run the method inside of the class. Yeah. If it's a private method, let me go back to that project if it's still open. If I come in here and I go, let's just do this one here, cut.
make it plus.
Or if you make it plus, it makes it private, yeah.
But still it gives some errors.
Can you make it plus and run?
If you make it plus, it actually means something else. Actually, this is going to give me an
No,
error
not
because it's
here
been
now.
between here. Wait a minute, hold on a second.
Because if I make plus here, it's not gonna run in the main class.
It's not going to run because you've made it this. Okay, so this is a method that's run from the instance. This is a method that's run from the class. So it's different than public, private, and protected because it's running from a class. It's like static in Java. You can make this one. You can make this one private. Let me refresh my memory because I don't actually have the syntax in front of me here. Nope, you can't do that. I don't want to give it away. I don't want to give you the answer either. Let me not do that for you. Let me not do that for you. But it's not the class. It's not the class. It's the it's a private method that you're going to create. I'm not going to show you the syntax because actually right now my brain is too fried anyway. But long story short,
Yeah, because I was trying like a private class.
Oh, no,
and I
no,
got stuck, so.
the class, it kind of defeats the purpose of the class. If it's private. The only reason why you'd want to make a private class is if you were going to use it inside of another class, nest the class inside of another class, and then that class can't be used outside of the class. It can only be used inside of the class, like a subclass, but not a subclass from inheritance purposes, but a nested class. That would be a nice private one. The methods, you want to make it so that, if I had a private method actually, This one here would run the method. In fact, if I hadn't deleted that method here, actually, let me take that method out, actually. Here, I'll make another method here. I'll make this one, though. Integer my method. And back over here, this is not a private one. This is a public one.
Yeah.
What if I went integer my method? If my method were private, I'd make the call in here. My method. My if I were to run it inside, I don't believe you have to run it inside of the class, do you? I don't think the instructions actually went that far. Let's see. Did you actually have to make an instance of it? Or use the class? Let's see. From main method in main, create an instance of the class and demonstrate all the methods. Yeah. If it were a private method, you're going to run that method inside of one of the other classes. So you'd have some way of running. Because the private method isn't going to work outside of the class.
So I directly wrote in the main class.
Ah.
I directly wrote one method
In the main class?
Yeah, in the main I written a method saying this.
That works. Oh, you did a class one.
Then it's not good.
Instead of writing that private in the implement, she wrote directly in the main.
Oh. That's one way of doing it. It actually works.
It works, but that's
It's not really the design, but I'll take that. I'll take that if you want to do it that way. But you should be able to figure out how to put it in here and then run the method from one of the private methods. Or run the method within the class.
I tried giving instead of minus, I tried giving plus.
And also
Even
cheat.
I spent some time with first assignment and then I jumped to second.
You can also cheat and go like this too. That's really a private method there. It's not really part of the object. It's technically private. It's not accessible by the object. It's not inside of the object implementation. It's private. So this one say print f print me.
So if it is outside the implementation, then it's private.
It's not accessible inside of the class.
Oh. Okay.
And then I run print me on here. I believe this will work. This is just hacking it.
Can you make it plus and run? Because if you didn't give any signage, it's default. It's public.
Actually, this one's going to tell me it's invalid. Invalid declaration of function print me. Well, I can't do that actually. Yeah. No, this is technically private for the class. Yeah.
Okay.
It's what you did actually, but you put it in main. I think you put it in the class declaration. There's also a way of making it private. My method is what I wanted to run. So let's see. A.myMethod. Let's see. We're just hacking it now. You know what? Just we'll use. Well, actually, I forgot. Like, what language am I programming in here? I'm programming in that language, and so then print me ended up here. But I can't do this though. I don't think I can do this. What was it called? Print me. It'll say not visible. It's private. Where's it private too? It's private inside of this. It's a cheat way of doing it, but it's private inside of this class. Oops. This class right here.
No, it's small.
Oh, did I do it wrong? Ah, okay, wait a minute. Wait, it should not. It should give me the same message though. Did it not? It should give me the same message. No visible interface for access declares the selector print me. It's not visible. It's there, but it's not visible, which means it's private. It's not public. So if I did this, put it inside the instance of the, well, I'd have to change the format for it, put it in Objective-C to actually put it in the instance of the Objective-C class. in terms of the implementation, make it into a method that's part of the class, which is, here we go. Let's just do it. If I moved it down here, you know what? Let's just do this. Copy. It might complain actually because it's not in the .h file. Print me. No, it didn't complain. What's over here? Control. Yeah, I know, because we don't have a return here. Return 0, because it's an integer data type up here. It wants a return 0 in there. Okay. Now if I run it, it should work, because I put it inside of the implementation. Now it's public actually, because of the where it's located. Now it's going to say, what did I call it with a capital P, or did I put a small p in there? Let's just change it to a capital P. Make sure we got a different one here. Print me. Print me. Okay, looks good. Oops, not build. Oh well. Let me clean it. Clean successful. Oh, no, what's wrong here? Maybe it's the name. Oh, it's not in here. It's not actually in the .h file. Alright, hold on 1 second. We'll get this to work.
So this is different method.
Yeah, I created a different one. I print me. We have 2 of them actually. One of them is going to work because one of them is public and the other one's private. It's only this is private. It's only accessible within this class implementation. This doesn't have to go in the .h file because it's not part of the implementation. It's just like an extra function. In fact, this is in C syntax as well out here. So it kind of demonstrates the use of C inside of Objective-C as well. Because this is a function, it has nothing to do, or it's a method actually, but it's also a function. It has nothing to do with the method. So there we go. Now if I run it, I should put like a line. Hold on, let me fix this method here. We put a line return, what is it, /n over here. Here, print me. Here, I'll put in here, print me please. There we go. So we know which one this one is. Actually, you know what, I'll put the line. This is going to give me a line return. There we go. Let's go back to main, make sure I got both of them working here. Actually, one of them is going to give me an error. I can't do it. But my method's going to run the first one. Print me is going to run the second one. Now I should have some better looking results. And here we go. I got print me please. One of them is technically private.
Thank you.
No problem. I've solved that one for you. Technically that would actually work for this solution, by the way, because it's not mentioning anything. No restrictions are limited here. You can actually put it private inside as a method as well. And it would actually perform the same way. But that also works. So let's see, that one was access. That one here.
It's not one. Like both of us thought it's a private class. Can you imagine?
Class? Yeah. No, actually it says method on it though.
Yes.
It looks like a constructors.
So I was like, oh, how to make the.
Why would you make a class private though?
I don't even know.
Maybe you were thinking, you're just like, she asked for a private class, let me give her a private class.
Yeah, after creating a private class, I'm not able to implement on the main and.
No, you can't do anything. You can't do anything with a private class in main.
Yes.
But you saw I ran that private method in main.
Mhm,
Yeah.
yes.
By running it through a public method called the private method.
So what's the use of making any class private?
Well, in that
There's an
particular
option to make
case, there's an option to make it private. In that particular case, that particular method is not doing anything other than print me please to the screen or something like that. But if it was doing some algorithm or some calculation that was only useful inside of the class, that would make sense. You know, like but if you didn't want to use it, it's not part of the object. Like sometimes like a print something, like a print the object details to the screen. Well, that would probably be part of the object actually.
No, I'm asking why
Oh.
make any class private. There is an option to make it private
Oh, yes.
class, but why, when we cannot.
Well, as I was
make it
mentioning before, the only one I can think of on the fly would be using the class inside of another class. And you didn't want to use the class as a main class. It was just going to be like maybe you had a private date class and you created instances of the date inside of another class and you had the class defined in the
Almost
class.
how we are doing the method, calling another method like that. If
Yeah.
you call the private
Correct.
into
And you
okay.
needed to use that class for an object type that did something like date or something. I don't know. That's the only reason. I mean, personally, I don't know when you don't want to use a private class because
I
it's
think
pretty
when
useless.
We don't want to show the code and we keep that in a private and we just call
Protected classes, I say, yeah. Protected classes are visible through inheritance. They're just not visible in main. So if you're protected, I can see that kind of logic. Because maybe you're not the done. You're not the end class. You're just part of the building blocks. And we don't want anyone to make an instance of this object and we make it protected. Same thing with the data. We don't want to use it for anything, but it's part of something else. And we're going to use it in inheritance or we're going to use it for something. It's a building block. So, all right, constructors. Let's see what constructors does before we start looking at the code. It's again fractions and complex numbers, I believe. No, it's just fractions. Fraction is 1/3, fraction 2 is 1/5, and fraction number 3 is 3/10. Well, 3 instances of the same object here. Instance number 1 is called fraction, fraction 2, fraction 3, and when we call it, we got this one calling with init, and then we have init with numerator 3. And so we've seen this example already, actually, but we're looking at the concept of being able to initialize it 2 instances without using init with number, a numerator, init with denominator. We have a set and a getter here. We just sent it one though. We just sent it. Let me take a look here. We sent it. Oh no, we sent it both. So I was gonna say we should have sent it both. Numerator's word wrapped, so it wasn't on the same line, but I fixed that. So now we have init with numerator 3, denominator 10. If we leave out one, we're going to get a message, an error message. But we could create another constructor that only had this one and set this one to 0 or something. If we did that, it's actually kind of easy. We come over here, and we would create another one of these guys here that looked different and only had 1 instead of 2. So, but it's just basically showing you another example of constructors, which are nothing than another form of an initializer. We know it's an initializer because of the init in it here. So the implementation of this one here is kind of same as the other examples for the fraction. Actually, it's the same fraction in code. It's just showing you it's repeating it for the initializer kind of concept. But there's nothing really much new to explain on this one, actually. We're not even using ID with this one. Now instead on fraction here, we're setting the numerator, setting the denominator. Fraction number 2, we're doing a combo, set numerator 1, set denominator 5. Personally, I think this is the easiest way of doing it here, because you're setting them both when you're creating it, instead of having to set them after you create it. Okay. Alright. Questions on initializers? Those are pretty easy at this point, huh? Every single one of your programs will have to have an initializer. That's why I thought maybe I should give you some initializer examples. Alright, what else we got? There's constructors here. If you want a simple class example, here you go. What is the simple class example doing? For those of you who are completely lost and haven't been able to make a class yet, and there's probably some out there, this is about as simple as you can get. However, there's a little trick to this one. This one has a plus next to it, which is demonstrating not only the class concept, but this is class level. So it's class level, not instance level methods. So plus, this is a static integer count, and then we have, and static means the same thing in Objective-C as it does in C, and it means the same thing in Java actually. It means class level. And notice this is outside of the class object. So this is the one time you'll actually see pluses. You don't normally see the pluses, you usually see the minuses, because usually we're making methods that go inside of objects that the objects are going to run these methods, right? So let's see how it works. We have a method integer count, and then we have initialize. Another method here. What's the class going to be here? We have implementation class A. This is class A.h. It's inheriting from NS object. And init in here is going to set the counter plus plus and return self. Init count, return the count, initialize and make it 0. Initialize is going to set the count and make it 0. In order to get at this little static piece of information up here, these guys have to be class level methods with the plus sign. Otherwise we can't modify this. Same rule applies to Java actually and to C++. So, which is the reason why these are static, now I'm speaking Java. The reason why these are class level and not instance levels, if they were instance levels they'd look like this. They'd have a minus sign next to them. So, and if you're using a plus sign and you're thinking you're making an instance variable, well, you're on the wrong track. This is the good part here. Let's take a look at this in main. It's going to tell me I'm not doing anything with it. Unused. Yes, I know it's unused. Just making some instances. So we have class A, we have 2 instances of this, and we're going to make some instances of this. And we're going to go, oh, okay. So then we're going to do from class A, this is the trick here. We didn't actually have to make any instances. Do we have to make any? No, let's see. Hold on one second. We don't have to make any instances of anything in this example. I started out making instances and then I thought, you know what, I don't need any instances here. We don't have to make no instances of anything here. Instead we're running from the class A, initialize the count, class A, initialize the count. If we run it, I think it's going to be 0. We haven't really done anything to it. Let's see, 0. 0. I don't think we're doing anything in here. We're initializing, is our initializer, hold on, is our initializer incrementing it? I think our initializer, which is the reason why those methods are created. Let's take a look at the init, actually. The init is doing count plus plus. So for each new object, each new instances of the objects that are getting created, initializer is incrementing it through this instance method here, the init. So this should actually give us now 2, 3. And it's a static variable count that's shared between all the objects. So that's why those 2 instances were created. They don't do anything, they're just showing you how count is being incremented. So if it was a student ID, you can keep track of student IDs and stuff like that way. It's very similar to what we did with static, and actually we have done a count actually in Java class last term. So questions about static integer I, or what is counter?
Every time when you want to make a count, we have to create initializer like that.
Then no, this is just one way. You can do it within a method.
If we put at 10 and if we...
As long as this is within something the object has access to, I could do this actually. Watch this. I could do. Well, let me put it in the H to make it kosher here. Ooh.
If I want count equal to 10,
Yeah.
so every time I have to initialize in a main program, or
No, you just write a method does it. That's what I was going to show you. Like increment. Let's just call this void. Oops. I'm going to call this one increment. And I'm going to go over here. This is a instance method increment. Right. I'm going to go over here. I'm going to, let's see, I'm going to say, what was a void? Yeah. Increments. Count. Oops. I know I misspelled void. I told you I was a terrible typist. Void. Hold on a second. Okay. And now we're going to go count is equal to count plus 10. You want to increment it by 10, right? And then out here in main, I'm going to run, let's just do this here. C1, because it's complaining that I'm not using the objects, so why not? C1, increment. And then a C2, increment. Well, that's enough. Now the number's going to get real big, because it's by 10. 22 and 33. Oh, is that right? Yeah, that is right. No? Yeah, it is right. It's printing out the count class after this increment here. Wait a minute, by 10.
No, it is incrementing twice and then it's taking the 8.
Yes, it is. It is.
So if you don't take that C2, then it's give only 12.
Yeah. Mm. Anyway, you understand what I'm doing. So it's being used inside of here through a method call rather than through, you don't have to use the initializer
So
for that.
whatever you're changing, are we going to get those for the means when you want to download whatever you're changing now?
Oh no, you're not going to get it. I've been. No, come on, you can write that.
Okay.
You can write that.
I'm not writing on the paper.
Oh.
Okay.
You can see in the video.
In the video, I think.
You can see in the video. Ah, watch the video. Watch the video. Yes.
That's
Okay.
Actually, you'll see exactly what I just did in the video all over again, as many times as you want. All right.
Okay.
Let's look at a dictionary. How's that? Dictionaries. Another data type. So you missed the arrays. We looked at mutable and non-mutable arrays before you came in. Or maybe that was while you were coming in. So let's talk about dictionaries. The spacing on this one is kind of weird, but we have an NS dictionary here. And we don't have any classes in here. You notice everything's in main. And up here we've got foundation, NS dictionary, and NS enumeration. We talked about the enumeration a little bit earlier. We have a method here. Method? Function, actually. Function here. Not really a method because we only have one object main. There's no class objects in this. No instances of any objects or anything, actually. But we do have a function called print, and it's going to print out. Remember that array? It printed out an NS array? Well, this is going to print out an NS dictionary. We're going to pass through it a map. A dictionary is essentially a key-value combination. So we load a bunch of keys in there and we assign some values to it. It's like a lookup table. Nice structure. Doesn't exist in C++. It does exist in Java, but you got to import a package for it. So, and here you have to import NS enumeration. Well, actually, no, it's not part of Foundation. So you have to use these includes. Okay, so what are we going to do here? We got the ID set to key. So we're going to use an ID in here. And NS enumeration map. We're going to call the map. The map is an enumeration data type, which is going to hold many multiple values, like 0, 1, indexed, 0, 1, 2, 3. So it's sort of like a lightweight array without the array structure. It's an enumeration. And then it's going to be a key enumeration. So let's see, while the key enumeration next object, same thing as we did actually in the previous example with the arrays. We used an enumeration for it. Print out the object. We're going to print out all the string equivalents for the description. And then map for key, then the key, and then the description of the key. So the two components essentially. If we look at the dictionary component here, we have 1 with 1, 2 with 2, 3 with 3, and then we're going to do an NS mutable dictionary. So for each one of the dictionaries here, just like the array, we had NS array and then we had NS mutable array. We have the standard lightweight dictionary, and then we have the dictionary that's changeable. And the changeable dictionary here, we're going to print out, this is the static dictionary. Maybe I should have printed this first. I'll run it in a few minutes so you can see what this output is and we can go back and take a look here. But we're going to print same example that was used with the arrays, identical, but it's now a dictionary instead of an array. Add some objects to the mutable array. So we got Tom and Bob, and these are just some generic names. And then print out the mutable array here. So print mutable. So let's run it. You can actually kind of see what's going on here. So we have static 3, 2, 1, which is equal to the 3, and this is being printed out to the screen, by the way, up here. In our print here, see this little symbol here? It's nothing fancy. It's in a printf.
Yes, but why did it print 3, 1, and 2? Why not it's 1, 2, 3?
Because the key value was set to the ones. So your number with integer I, so NS number was created for the key. So 1 was 1, 2 was 2, 3 was 3. And those are the objects in here. Actually, this is printed in the reverse order, I think. Actually, no, it isn't. Yeah, no, it's key map. So the key is the first item. This is the first item that's being printed out, which is the key, and then the second item is the value for the key.
Okay, but even the string is not in order, or else if we are not printing anything.
Oh, Here's the interesting thing. In fact, glad you noticed, actually. It's not going to be in order. Dictionaries have no order associated with them. They're not meant to be an array. They're not an array. There's no, what you're saying is 1, 2, 3, 3, 1, 2. If I run it again, I might actually come out with a different order. Let's see. 3, 1, 2. No, it's the same order. It doesn't really matter. It's just, it's meant to be ordered. There's no structured, it's not an ordered list. It's like a database. You know, like when you populate a table in a database? I don't know what order. You put them in this order, but they don't come out in that order.
Okay.
It's hashed with the data storage of the runtime environment, so it's dynamically allocated, and you added it to the dictionary. So you don't pull, normally you don't print it out this way either. You'd ask the dictionary, hey, is 1 in there? Return the value of 1. It comes back and says 1, you know. It doesn't, you're basically looking up information by the key value, and it's returning, by the key, and it's returning the value that's associated with it in a lookup kind of table manner. Not really. If this were really the case, I would probably do it use an array for this, and not really a dictionary. So the example's kind of stupid that way. It should really be an array, actually, but then I wouldn't be showing you dictionaries. But no, good observation. Thank you for bringing it up, because I forgot to mention it. This order is undetermined. You can't determine the order.
Yes. It's just for storing purpose, I think.
Yep. This is the way it was stored, actually. You know, if I run it again, 3, 1, 2.
No, can you just
3, 1, 2. Yeah.
Can you just add one more thing and see how it's gonna come in the beginning, or like where it's just 4? Yeah.
4.
I know I can do at my home, but I'm just curious.
No, actually, I'm sort of curious too. I'm going to cut and paste here. Copy. I believe our loop is set to look for the next item, so it should work just fine. In this particular case, let me just make sure the loop is correct. Set next object, so it should go. We'll see. So I added 4. I'll put it on the end.
But the beginning are not in order.
You know what? Let's do this. Here, let's do this. Now I'm kind of curious, actually. I don't think, this is like a guessing game, though.
Yeah.
0. There we go. Let's see what happens with this. 0. Alright. There's no rhyme or reason to it, though. You can't predict it. In fact, maybe it's because it's not garbage collected. Let's see. I recently found this clean button, by the way. I love it. When there's an error, you fix the error, but Xcode hasn't updated yet, just clean. It's under product. Clean.
Yes.
Yeah. Solves all problems. And see, it's recompiling it from scratch. 3, 2, 1. What was it before?
It was like
3, 1, 2.
No, it was like 3, 1, 2.
Now it's 3, 2, 1, 4, 0.
Yeah, it's something else order, so it's not in alphabetical.
No, it's not alphabetical. No, it's completely unpredictable, actually.
Yes.
And then the mutable part of it, we're just adding adding 2 more things to the object itself, Tom, and some other stuff. So, and the mutable dictionary. So. The mutable dictionary, is it? No, it's just a new one here. Mutable dictionary, mutable. So basically, I made one where we can change the size of it and stuff. But you know what? Though this one here, we'd have to do it in the initialization, like what we just did. And you can still change the size of it, but mutable ones you can add to it after you create it. So this one here is interesting to note here. We've created it with object keys, with object and keys, and we're running the method with the initializer to set the values. In this one here, we've created it no values. It's mutable. So we added the values to it after we created it. So we can go through the entire program and just start adding items to it. And it can grow as big as we want it because it's mutable.
But it did add it to the before one, so what's the use
No,
of
there's 2
adding
different
it?
ones.
Yeah, 2 different ones.
Yeah. If I did this, let me do it this way.
The key, I think it will add to the before ones.
Well, let's see what happens. I believe I'm going to get an error message, but I'm going to go dictionary if I spell it correctly. Dictionary. Set I don't know if that one. Let's just here set ID. Oh, let's call it 1. No, let's call it 5. And the string. Let's go test. What did I do wrong here? Bracket, thank you. I think I have to do this. No, I don't have to do this, do I? No? Okay. I don't remember the syntax off the top of my head. Let's see what this says. Incompatible integer to pointer conversion, sending int to type ID.
Okay,
I don't think it's going to take a string either, is it? No, it will take a string. Dictionary. So, okay, let's see what happens here. I think it's going to give us an error message. It does give us an error message. Nasty little error message, although you see it did compile correctly and it did run, but it's not immutable. So it's going to give us terminating app due to uncaught exception, internal inconsistency exception, reason of the dictionary, mutating method sent to immutable object. Means that that is not a mutable dictionary object. So the same thing doesn't work after you've already initialized it. So you can't. That's the difference between the mutable and the unmutable. Same concept applies towards the arrays. So we have the mutable array and the non-mutable array. So most people get by that with just creating mutable everything. So stop. Okay. So that was the dictionary. So moving right along. I believe I showed you guys categories last time. Well, let's look at private actually. Did we look at private yet? I believe private might actually have the private method in there, but let me just take a quick look here actually. Public method. And then we have, this is class.m. And then we have private methods. Where we have the word private, and here's your syntax. I didn't know I gave this to you, but I guess I did, and I couldn't remember it actually. Here's your answer to that question. But we already found a workaround. You could do it that way, or you could do it this way. Just use the keyword private in here. I thought that was what it was. I couldn't remember. Syntax is all the same actually. So these are private methods, and those are public ones and we still have the minus here actually, because they all belong to the same class. These are the methods themselves. Actually, technically, the first one I did was really a function, not a method. So use this method here, actually. And what happens out here? Well, you're going to get an error message if you try to run this. So when you run it, it says a public method, which is what we created a method called myClass. Of type myClass, we called it OBG. Object, allocated it, we ran the public method, and the public method of this class prints out to the screen, public method. And then the private method, well, here's what it's going to do actually. It's not going to print anything, it's going to give us an error message. So if I go like this, oh, I am going to get a problem here actually. No visible interface for my class declared in. Well, that's the same message we got with the other function too. They're both private. So this is technically the method version of the function. So either way you want to do it, works just fine. So the key word here is, or the key to this whole thing is the public is not in the .h file because it's not part of the implementation. So the interface has got the public method in here, and the implementation we just added. And it's still within the interface. Oh. Ooh. That's non-standard. I thought I had this over there. Well, okay, so we have an interface and an implementation for the private stuff that's actually demonstrating another point I haven't actually mentioned yet. See how you have in the .h file? In fact, people in the iPhone class have seen this already because you accidentally drag a connection over and wire it to the .m instead of the .h. And what you've got is an implementation and an interface all together, because it's going to create the interface for you. So here we have the interface over here, and then over here we have the implementation, and then we have another interface, and then we have an it doesn't actually matter where it goes as long as you have a set. So this was done together. You can actually move this one over into the other one, but it's kept separately because they're supposed to demonstrate to you the private methods. So, private versus public. So. This is actually cleaner as well, I think. So you can do it this way if you want in the assignment. Or you can put it all together, it doesn't really matter. Just, you know, the keyword private here is what's basically differentiating us.
But you're not able to do the private method of this.
No. Only works inside of the class. You'd have to run the private method inside
Oh,
of.
so if I put all this stuff within the implementation, then it's what? You meant to say?
Let's see. Private method.
No, you have to put the interface even in the implementation.
I'm sorry?
I think the implementation part should be in interface part should be in implementation, I think.
It needs to be for this particular case. It does because this class here, my
Yes.
class, is private.
Private,
Yeah, we've made a public and a private version of the same class, but because we did that, the methods that are inside of it are private. Which was kind of another workaround, actually, if you think about it. What is this going to tell me? Implicit declaration of function is invalid. Yes, I know it's invalid. You could run those, okay, the private methods are not going to run in main, but you can run them from within inside of the public class as long as it's defined within the same class body. Which is how,
So you meant to say that whole code, which is interface and implementation for the private code, should be in a public implementation?
well, unfortunately I misled you because I failed to realize that it's the class itself that's become private. And here we have a public version and a private version of the class interface. So this interface here and this interface here don't match.
Yes.
So this one is the one that's going to be the public interface with the public implementation. This one's going to be the private one. So it has to be kept separately. Otherwise you're going to make the public private. So one of the interfaces is public and the other one is private.
So what's the use of making it
I have
private
no
then?
idea. You did? No, seriously, there's no reason, there's no rhyme to reason in this particular example because it's not being used for anything. But let's say I had some functionality that I wanted to keep private with inside of the class
I
implementation.
think the first one which you gave the example, that is fine.
It's
Make
more
a
logical to
function,
me. Yeah. In
make
fact,
a
it's
function
really
and-
doing the same thing, but instead of making it the interface to the class and the implementation to the class, I just put it in the class, but I put it outside of the implementation. Anything inside of the implementation and the interface that is public is public.
Yes.
So pull it out of there and it's private.
Yes.
That's the trick that I did on the first one.
Okay.
This is the same thing, except for now we're making a private interface and a private implementation instead. So otherwise, we would have just kept it. If we did this, we're going to get an error message, I believe, because we've already got an interface defined. Yeah, it's going to say duplicate interface definition. And if that were the case, then we pull
No,
this
change
stuff.
the class name, I think it won't say. Because
No, but it's
was
going to be a
changed.
different object, though. It's still my class. This is what I was saying before, taking this and putting it over here. This is not going to work, though, because in order for this to really work, we'd have to make the whole thing public or the whole thing private. See, now I got rid of the interface. And now I have the implementation down here. Now I'm going to get a little message that's going to tell me
No, just change
category
the-
is implementing the class, which is also, well, it's going to tell me it's public and private. Are you saying do this?
No, because you gave the same class name that stays telling it's duplicate. In the
No, the problem is I have,
both interface names was same. My class.
correct. They were before too,
Yes.
but one was public, one was private.
No, the names was same. I was telling like if you change the name, I think.
Oh yeah, but then you'd have two separate classes though.
We are implementing
You'd have, if you changed the name of the class, then you'd have two
No,
separate.
when you removed the private, it was saying it's duplicate names.
Yeah, it was duplicate.
Because the names was same.
I know.
Class- okay.
Then
You
it's
can't have
different
two the
classes.
same if they're
That's what
identical.
I'm telling like after you remove the
Yeah?
Just name the class.
If I rename the name of the class, I'm making a new class.
That's why we are having two classes, two different classes.
If I put them together, they're going to be all public or they're going to be all private. So I put them together. Now they're all public.
Yeah. Now I got it.
If I want to change it to private, I go like this. Now it's all or nothing. Now it's all private. Well, I have to change this in here too as well. Well, actually I don't, but it's going to tell me a message. What's it going to say? Category is implementing a method which is also implemented in the primary, whatever. This is really the wrong syntax for it, but hopefully you understand what I'm doing. Okay, I think the aha came on a few minutes ago, so
Yes.
we'll leave that one alone. All right, so we have variables and properties. It's already 6:41 though. Do you guys want to? Did you have enough for today? This is today
Just
Wednesday.
finished it.
Well, let's just finish this up then. Okay, we'll just go through quickly. This is going to be a category example, I believe. No, variables and properties. So we have a cat here in this object, and it has age and a name, and some properties, and we have a strong and a, okay, so we're going to print out the name and the age of the cat. So this is actually kind of simple. It's using synthesize and properties, and it's going to tell us that we can create cat fuzzy, and we can run fuzzy.name, fuzzy.age, or we can print name, we can run fluffy. So we've actually seen this one before. So this was no-brainer. This is an easy one. So that's this one here. And then exceptions. I believe we talked about exception handling a couple lectures ago, but we never actually saw the exceptions themselves. This is actually, yeah, using the try and the catch, but I'm running it here so you can see what's going on. Purposely throwing exception, so we have cup levels, this, and then we're going to throw an exception here that's going to tell us that our cup level, cup warning exception, cup level is 50, cup level is 60, cup overflow, the overflow exception. We're making up our own exceptions. So
If it's more than 40.
yeah, so in here, I believe this actually comes around with nothing really in these classes here, except it's just a warning. So in the implementation here we have the cup. The cup's going to have a level, and we're going to set the level here. And this is where we're going to get, so level is equal to 1, set the level. If the level is larger than 100, then the NS exception, and we're creating an NS exception object E, and that's going to be throwing our cup overflow exception, and it's going to print out this information. And then we're defining the cup warning exception. So basically we're using a try and catch, we're defining our own exceptions, and we're throwing our own exceptions. And the implementation of that kind of looks like that. And then the main program, it's just making some instances of the objects and then catching, catch this one, catch this one. So instead of using built-in exceptions like an IO exception or something, we're throwing our own exceptions, which is kind of nice. I don't believe I have you throwing any exceptions in any of the assignments. Last but not least, category. I showed you category with a, I don't know if I showed you guys this example though. We talked about categories and okay, we talked about categories, I think, and protocols and categories at one point. So we have math, we have function math, so we have add, multiply, divide. We have implementation of that, so we have the function add, multiply, divide. So in the fraction, numerator in here, and here we have an interface fraction for the object, and we have a fraction implementation. And then where's the category here? This one might be mislabeled. This particular example is only making a couple of fractions here, it looks like. And it's printing out the fractions. Hold on one second. Hold on one second. Fraction. Numerator and denominator. I may have mislabeled this one. I don't see the implementation as I thought it was. Ignore this. Oh no, it's here it is. Here's the category. It's implementing math. So our implementation is using a category, which is like a importing a library in, essentially, which is math, and math is going to be performing those calculations for us for the functionality. So this is where that's coming in. So we're not inheriting, we're just building a plus, a minus off of a category that we're using, essentially. So don't have to work with categories in any of the, that's where that's coming in. Otherwise, if we weren't doing it, it would look like that, actually. But we have to implement the category. Duplicate interface, yes, I know. Let's just leave it alone. Anyway, so don't have to work with categories either, but that was a learning objective for today, and you can download the file and you can play with those all you want, and you can use those code in your implementation of your assignments if you'd like. So it was meant to help you, because on the 27th of this month, and bringing up the old calendar here, not next week, but the following week, on August 27th is your final exam, and the date that all your assignments are due, which means you should be working on assignments right now. Next week, on the 22nd or the 20th, your choice. Actually, you got to run the final exam review? We'll do it on the 22nd. Final exam review for this class will be on the 22nd. Probably be the same for the next class, too, because I want to do them all, both on the same day, which makes a lot of sense. So, questions, comments, or concerns? We're done for today.
Thank you.
You're welcome.